Okay, let's get started. Hi everyone, welcome to Auto session. So this is a hybrid meeting, and my name is Qing Wu. Join with me online, we have Yan Sidov and Mohammed Bogdel, and we will host remotely. And actually in the room, we have Judy actually to coordinate and to manage the meeting echo. So thanks, Jody, for volunteer. Very appreciate. Note where, and probably already familiar with this. If you make any contribution, and please make sure you follow IETF rules. And if you have IPR, please disclose it. Code conduct, and when you make a contribution or you make comments to others topics, please be friendly and focus on technical discussion. Administrative, and as usual, we'll use MIDI echo to for the queue control. If you do the presentation or make comments, please enter into the queue and by pressing the raise button. And if you speak, please identify yourself. And when you stop the speaker, please mute yourself. And for JavaScript and we administrator, we actually have Daniel King and Richard to help take a minute. So thanks, Dan and Richard. And Jabber, any volunteer for Jabber? Actually, I think Drew can help to watch the Jabber. Yeah. Blue sheet. Actually, we have electric blue sheet. Please make sure you join the media echo, so your attendance will be automatically recorded. And if you attend them in person, please make sure you join the media echo as well. And work remotely, actually, as we know, actually most of the work actually will be done on the mailing list. Please leverage the mailing list. If you have any new idea, please introduce your idea on the mailing list. And for working group job, it's important to raise the discussion on the list to resolve any open issue. And for informal meeting, we actually already have a weekly WebEx meeting, and to facilitate the charter item progress. And for online meeting, if you think you have any good proposal, can fit it into the auto charter, and you can request the chair to schedule the online meeting. So we are happy to do this. IPR disclosure, and so this meeting agenda for today's discussion will focus on charter items, and two items will be discussed. One is Autoimm support, the second is auto new transport. And also we actually have deployment experience update, and this is also part of our auto charter. And if we still have time, actually we will discuss a new non-charter item, which actually introduce a new idea to discuss how to integrate the G2 into the auto. And also we have auto-related activity. Actually, we have computer-aware networking both. Actually, this will be introduced by Luis. So any agenda batch? Okay, let's move on. For document update, and since the last IETF meeting, we actually moved 4 existing work items to the RFC queue. So thanks for the author and editor for tremendous effort, and we finally deliver this full work. So let's give applause to all the author and editors. And also, in addition, we have a new work item to be adopted, which is a cost model draft. This actually is a companion draft for the path vector. And we already initiated the adoption call before this meeting. Actually, this has already have a 0.0 working group draft. And our chair's plan is we will immediately initiate the working group last call right after this meeting. For new errata, actually, we got 4 new errata. Actually, all of these errata actually are related to the auto base protocol. And so for the first one, actually raised by the Samuel during his security director review, he identified a typo. Actually, this need to be verified. And also for another one, another 2 actually relate to the course mode. Actually, we need to make update to the auto base protocol. It's kind of typo. Already, this has been discussed on the list with auto base protocol author. And for all of these 3, I think this need to be verified by our AD. So any comments on this? Milestone update, actually. Currently, we already have 3 milestone, and but because of the existing work item, actually, we take quite a long time, actually. So so we chair actually suggest we can make a milestone update. In addition, we actually introduce a new work item, the cost mode specification. And this has already discussed with our AD and set the milestone. So we propose the milestone actually to change the time frame. So any suggestion for this, any input or opinion on this proposed milestone? Last one, actually, we chair discuss actually how to socialize auto. Actually, we really want to increase more visibility to the auto activity. And our proposal actually is disseminate this worker to all the other area in IETF, and we also need to socialize this auto to the operator community and application developer community. And we actually have a SICOM AI actually proposed by the auto design team member, and this will be a continued effort. And but we need other venue to promote auto in operator community and application community. And in addition, we seek more volunteer to build the auto tutorial actually, and this will be discussed in, for example, ops area, art area, or some other venues. And if you have any input to, please let us know. In addition, actually, we will consider to edit a paper in IETF journal, and we can hold the pen, but we need input from the auto design team and auto community. So I see, Luis, do you have any comments on this?
Yes, I think this is Luis Contreras from Telefónica. Yeah, we were talking, Jordi and me, about the different potential venues that we are identifying here in this meeting precisely. So our proposal would be maybe to, in one of our weekly calls, to make a proposal, maybe a survey of what could be potential, let's say, targets to socialize Alto with different working groups here, also even research groups from IETF. So just to comment our proposal of commenting maybe in one of our weekly calls and to plan some activity in that respect.
Okay. Thanks for input. Actually, I hope you will contribute to this kind of effort. Yeah. So any other opinion? If not, actually, we can kick off the discussion for agenda item. And I think the first one is Jason, right? Jason, so please take away.
Yeah, I just asked to share this slide.
Yeah, maybe I need to stop my sharing, right? Can you request again? Maybe.
Okay. I see. Okay, so hello everyone, this is Jason, and so this is a slide for the discussion about the new chapter item for the Autoimm and management data model. I work with Drew, Roland, and Kai, and we are working on this document right now. The quick summary about this document. The main goal for the document is to try to provide a young data model for the OM and the management of the Alto protocols. And latest version already uploaded to the data tracker. We also have the other copies on the GitHub, and in the recent version, we also include all the young module code. Also on the GitHub can be accessed. I think we can request some reviews for the initial version of the young code. And for the major changes since the latest between this latest version and our previous version. So why not change we change the document title from the OM to the ONM. So which means the OEM and management. Because we follow the guideline. This is comments from the Azure in the mailing list. So we check the guideline of the RFC 6291. So I think this document not just target to the OM, also include the management part. So we change this title to the ONM. Also revise the scope and requirements to be exactly aligned with the RFC 7285 and the RFC 7971. So it's also a common comments from many reviewers in the mailing list. So another major changes will make the initial YAML code ready. So I think it's ready to be reviewed. And also thanks to the Chupangma's contribution to the initial version. So this is the current basic requirement we post in the latest version. So you can see the basic requirements. We have the several requirements which align to the app system 285 and 7971. So all the references are given in the table. And we also have the additional requirements. So that's for the extensibility. So as the Alto protocol is extensible, so we also request the data model for the Alto ONM should allow for the augmentation to support the potential future extensions. So that's the current additional requirements. I think is very important for this document. And then, so this is the current status of our working progress for all of those requirements. So you can see we already have the initial proposal for the requirements 3, 5.1, 5.2, and 6 and 8. So right now we are working progress on the the first requirements and the 5.3 and the 7. 2 and 4, it's in our plan, but it's still in the to-do list. I'm not any proposal right now, but hope we can finish this by the next IETF meeting. So we want to use this slide to give a very quick overview about how we manage this data models. So how this data model can align to the auto server architectures. So the black box, each black box means a component in the auto server. So it's inside the data model scope. So this data model will provide the current document will provide the data model for those components like the server management, the information resource management, the performance monitor, the logging and fault management, and also the data source listener. So they will require the data model support. But in the auto scope, we also have them data brokers to define how to store and use this data collect from data sources, and also need some implement specific algorithm plugins to really define how to translate this data sources to the specific information resources. They are in the auto scope, but not in the scope of this data model document. And so this is the initial proposal we gave for the server setup, so which is the first requirement. So this part will define some meta information for the server level OEM and management, but it's still in work in progress. So you can see the current information where they only include some small piece of the required information. So we're trying to make it more comprehensive. Like we try to also include some HTTP server listen configurations, which is inspired by the RESTConf server data models. And also, we also need some DNS configurations for the server discovery, which is required by the RFC 86 and 86. And this one will be the major piece of this data model, which is provide the data model for the information resource management. And to achieve this, so that this is the requirement 5. So to achieve this, we separate it to the 3 pieces. One is how to define information resource. So we provide some common parameters for each resource and the resource specific parameters. And in each resource specific parameters, the operator need to specify what's the algorithm used to generate this information resource and which data sources can be used to generate this information resource. And for the server monitoring, the green landmark, so the list items marked in the green colors means it's already included in the current data model. And the item marked in the red colors means it's still work in progress. It's not still not in the current data models part, but we are trying to work on them to finish this by the next IETF meeting. So the meter piece, we still need some discussion about how which specific information need to be good for the measurement on impact, which is because some information will associate with the application performance. So that probably will be implementation related. Not so we try to summarize some common features from this measurement. So give some proposal. And another major pieces already included in the current data model is that the proposal for the requirement 8, which is how to provide the extensibility. So how to extend the current data model to support some future features like if the developer want to implement some specific algorithm to define how to generate the information resources. So the example shows how to augment the algorithm choice of the auto network parameters with a creation algorithm. So it's quite simple. So you just need to specify so which source ID should be used, and the source ID will link to a layer 3 network topology, which is defined in another YAML model. So it can be provided by the netcom, and we reference another individual draft which provide a reference algorithm implementation. So how to translate this the layer 3 network model to the auto information, the network map and the cost map. Yeah, so all of this is current progress we achieved for the current data model, but we still have some questions about how to proceed. So the first question actually generated recently in the mailing list, which is because this data model references several identities and enumeration types are defined, which are managed by the IANA registries. So to make this model extensible, so one question is that to remove them into a separate IANA managed data model like the IANA auto tabs, or we just keep it in the common data models. So we already asked the young doctors about what's the best practice for this. One argument that if we make the change, so it can make the update like the performance metrics and the cost updates, so it to be easy to support it without updating our basic common YAML module. But it also introduce some complexity, so we need some discuss for this part. So for chair, do we need to stop here and there's some discussion, or we just post out the questions and then we discuss?
Yeah, I see this issue you are already, sent to the list and also copy to the young doctor to get a confirmation. So we chair actually discuss with you and offline, and we have two proposals on the table. One is you can change the enumeration into the identity. The second is actually you define all of this type definition in the ANA module. So I think both proposal actually works, but we need to double check young doctor, get their feedback. I think we can open the floor to get any feedback if anyone to share the opinion.
Okay. So I see Richard asked a question. What's complexity when decompose? So Richard, can you explain a little bit? Not sure I understand your question.
So Richard, can you go to the mic? Richard, go ahead.
I heard Jensen when he discussed about the decomposition, he mentioned there could be some potential complexities. Therefore, I was wondering what kind of complexities. I think I saw some quick comments from Drew that there might be complexity. I think maybe there's some like a potential caveat that people need to pay attention. So what would that be? Being you mentioned about performance metrics. Performance metrics can have some complexity. For example, TCP throughput, right? A big part of configuration will be specify which TCP model. So there are all kind of issues. So what? Oh, okay. So therefore, I'm listening to see. Okay, I saw some comments by Matt as well, but I want to hear from you as well, Jensen. Go ahead.
Okay. Yeah, actually, the complexity is a part. Yeah, we need some discussion to get the feedback from the young doctors, because I see some documents, some young model proposed document will integrate the AI management into the single model, but some document will separate them. Yeah, I'm not sure what's the best practice.
Okay, I'll take it to the mailing list to discuss a bit more. Thank you.
Okay. So yeah, we can move this the more detailed discussion to the mailing list, and I just post some other questions here. Yeah. So one other question is about because a lot of parameters can be configured for the auto information generation. Yeah. But we need some principles for which one should be defined in the standard basic module, and which one should just delegate to the algorithm extensions, not be the common parameters. Like I see some one be suggested by the base protocols and also the RFC 7979. But yeah, for example, so each cost map should configure the default to PIDs, and also probably have some parameter to point out what's granularity for each network map and cost map, and also probably have some client-specific configuration to define the information resource level access control, so which client can request this information resource and which client cannot. Can be discussed by the client IP or some other metadata from the client. So I think we need to achieve some principles. So which one need to include in this data model, and which one is not in the scope should be moved to the algorithm extension.
So Jason, go back to the question.
Previous slide. Yeah, sure.
Yeah. Do we have a standard algorithm we can leverage it now?
What do you mean standard algorithm? Actually, this data model does not try to define any algorithm. So algorithm should not be in the scope of this data model. Actually, algorithm should always be some kind of extension.
Okay, maybe I'm misunderstood, but I think we can focus on basic parameter that has already been specified by auto-based protocol, and we can stick to the basic set, you know.
Yeah. Yes, do you have some comment? So do you want to speak?
Yeah, maybe you move to the next one. How do you have? How many slides do you have?
Yeah, actually, I just prepared the first three simple questions. So more discussions trying to move to the mailing list so can discuss more details. And this three one, I think it can be finished in the meetings. So another discussion about yeah. So far, all you can see the other requirements are for the auto servers. So we don't have any requirements for the auto client side. But actually, in the initial versions, we also mentioned that yeah, we try to include the auto client in the scope of this document. Because for our own parents, I think the auto client also do need some OEM. For example, we need to configure the cache management, the server discovery part, and if the auto client can access the multiple auto servers, also need some management for which one to be choice. So we think the OEM for the auto clients should also be important. But one thing I'm not sure is that if the YARN model is a good approach to expand for the client OEM.
Okay. Any comments for this question? I see Martin.
Martin Duke, Google. So I think you're asking the right questions here. But I think Chin's advice is good. You should strive to reduce the scope of this wherever you can. And if no one is willing to speak up for any of these particular features, you should probably just omit them. Make sure that they're extensible to support later. But I mean, like I said, if someone wants to speak up for this or for any of the other features, that's great. But otherwise, just leave it out. Thanks.
Okay, thanks for the comment.
Rachel?
I think Martin gave a very good, Richard Young from Yale. So Martin gave a wonderful comments and very good suggestions. I do want to, but somehow I do think the issue of how to configure auto clients, it's an interesting issue because that's an issue that we encountered during, Jensen yourself, right? And with Jordy to configure rules, right? For rules download command and a huge amount of back and forth about how to configure the rules client, and do we do using command line or do we use configuration file? What kind of parameter do we configure? They're clearly they are application specific. They're all different culture, right? Rules essentially command line from CERN, so they have different suggestions. So I think Martin's suggestion is great, but maybe there's some way to tell people exactly how. I think Drew mentioned the consistency across different YARN modules, and maybe here we can also suggest to people for different auto clients, for example, Ruzio, or we're working on some other applications as well. And what will be some common ways to configure auto client can be a very interesting way to move forward.
Yeah, I also think it's very important. Yeah.
Yeah, I tend to agree with Richard. Actually, otherwise, for normal client without auto protocol support can discover the auto server. There's no way to do this. You need some configuration for the auto client. Yeah. I see, Joe.
Hi. So one query which I had for the Alto working group to also guide us is whether the current Alto clients which are envisioned, do they already support Yang-based interfaces for OM techniques? If that is not the case, even if we write a Yang model, the issue would be that Yang model may not get deployed because these are the kind of client devices that do not use RESTConf or like the typical techniques that we have for Yang models. So this part was not very clear to me. So I would be looking for more feedback from people who are developing Alto clients to give us that feedback as well.
Yeah, that's a very good point. Yeah, that's also my concern because yeah, for my own experience, so far we are not using the Yang model to develop the client because some applications that try to leverage the auto server, the auto protocol, will not use the RESTConf or NetConf because they are more high level applications. Now some application for the network devices or the controllers or some things. So they are not using the Yang model to manage their own applications. So the clients also not use the Yang model so far. But probably some other applications will use the Yang model. So I'm not sure. Also raise this question to the working group to see if other people have some comments on this. Yeah.
And I think Med also mentioned that on the chat, it doesn't hurt us to create an Alto client Yang model. It will act as sort of an information model for even if somebody wants to use some other techniques. But this will be the common data that any Alto client must use. So sort of using Yang as an info model that we have standardized, but it's okay. But we would need more feedback from the working group so that we can do the right thing.
Yeah, I agree.
Okay. So Jody, do you have a quick comment? Actually, we run out of time for this topic.
Hi, Jordi from Qualcomm. Yeah, there was a conversation just a couple of days with Alberto and Fabio and Berta. Also, the idea of how do we not impose modifying the application to integrate with an Alto client, potentially providing like a proxy, so that you don't have to modify the application basically, so that the Alto client would run in a proxy. And then there's also conversations on edge computing, for instance, load balancing. So presentations at computing aware networking and so on about performing load balancing. And so the load balancer that decides how to steer traffic in the edge cloud could benefit from an Alto client implementation. So those are a couple of use cases that it's worth asking whether this would require some kind of good way to actually configure this specific use case, whether it's a proxy or an LB that could benefit from integration with an Alto client, basically. So thanks.
Okay, thanks. That's a very good input.
So Jason, you finish your slides?
Yeah, so that's just some proposal to update the milestones. Yeah, I think we already integrated into the share slide. Yeah. So try to make the main structure stable. Yeah, by the next IETF meeting and give the ready for that reviews by the December. Yeah. So thanks everyone, and you can give any feedback on mailing cities or open an issue in the GitHub. Yeah, thank you.
Okay, so for your request to adoption call, actually, we see a lot of interest for this work, and you guys make a lot of good progress. And we see actually maybe we can, initiate the adoption call after this meeting. So in the room, if anybody have some objection, please speak up, and otherwise we will proceed. Okay, thanks, Jason.
Okay, thanks, Jin.
Please stop sharing. So next topic is Ronan. Take away.
Yeah. Hello, everybody. The next slides are about Alto transport, and the draft is, in a nutshell, covering the topic how HTTP2 and Alto can be combined and work together. The work was done with Richard, Kai, and Jensen here. And my name is Roland Schott, and I will do the presentation today. I hope you can hear me because I have the mic here and I have the mask on, but if there's no complaint, I will do it in that way. Okay, then next slide, please. So as I stated, the motivation and requirements is that HTTP2 at the moment is not usable or not used for Alto. And this work tries to, or gives a proposal how this could be established and how it could work. And we want to introduce this the ideas that we have, and then have a discussion regarding this. The next slide. So just to recapitulate what is the status. So Alto based on the base RFCs, and we have here also RFC 8895, which already has introduced the server send event mechanism, SSE. We can see it here on the right-hand side, the Alto SSE example, but unfortunately this mechanism is only available for HTTP1. And the ISG review has considered to make a proposal how HTTP2 can work. And the idea is, in a way, to use what's already defined in Alto SSE, but make it available also with HTTP2. Okay, so before going into the details, just a double check to the requirements. For sure, we have also collected the requirements from the protocol. So a client can have an Alto resource connection as it is defined in RC 7285, and then all the requirements from Alto SSE. For example, start incremental update, stop an incremental update of a resource, and signaling of this stuff, and for sure have also ensured that the communication between server and client works well. And then from the Alto base framework, for sure using HTTP, we propose only to use a limited number of verbs. And now comes the HTTP design, the push promise mechanism that in a way will improve the transport or the optimization of the communication between the server and the client. And last but not least, there was also the idea to have some kind of capability negotiation. But when we go to the next slide, so at the moment our work covers these requirements, also 0 to 6, and the flexible deployment that's at the moment not covered in our work. So now we come to the design overview and the idea how to make it workable. Next slide, please. So when now going into this slide, you can see here above from the Alto server the current possibilities of the Alto server. We have information resources. We can have static resources like a network map, and also filterable resources like cost map. So this is the basic Alto functionality. And we have also the goal that we have a single HTTP connection between client and the Alto server, which tries to be addressed here with this HTTP connection overview. And the ambition is not to change here things, and have also the ambition to keep the HTTP2 protocol as it is. And then the idea is to have here some kind of intermediate layer between the Alto and HTTP2 that allows the server to use the HTTP2 connection. And the idea is to make the Alto SSE mechanism available for HTTP2. And we introduced or make the proposal of the introduction of the idea of transport queues. It is shown here in the picture. And by in a way implementing this transport queue in this information model, we have also let's say an incremental updates queue and receiver set information that is automatically created with when a transport queue is established. So various clients can connect to different, let's say, transport queues, and one client could also connect to different transport queues to get the different information. I hope that is clear, and now we will describe how this will work then in principle. But before doing this, the information structure. So client opens the connection to the server, the client opens and identifies the transport queue at itself, and then in principle, the client has manually read capabilities and request the status, for example, of the transport queue. The element in the message queue becomes a receiver. The client receives push updates from the server, and the client has a capability to close the transport queue or to close the connection. Okay, next slide then. And now we are showing how the transport queue is established. So the basic operations, we have here create, read, and delete operations. And similar to the Alto SSE, we have here a method in a way to create here a queue and the response of the server. So the client creates the queue by sending a request, and the server responds with the information of the transport queue, and this is more or less the JSON text that's used. Next slide. How does this look like? So the server request here, we have here post information, and the path is the transport queue that where the information of the server could be pushed to the client, and the server responses here with establishment of the transport queue to the client. This was already stated. Then we have also, as stated here, the client reads possibility, but also explicitly a delete of the transport queue. So the deletion of the transport queue is mainly also from the view of the client. So if other clients are connected to the transport queue, this transport queue as itself cannot be deleted because there are some dependencies. So the transport for a client is ephemeral, and in case the client deletes it, so from the client's view, he cannot expect that this transport queue is still valid. So the client has also the possibility to delete. Let's go then. The next slide will show the read option of the transport queue. Could you please go to the next slide? So here, transport queue example read. So when the transport queue is established, then the client has here the information of the appropriate transport queue, sends information to the server, and the server responds, for example, here with incremental update queues and the server set. And then we have here some sequence numbers with, let's say, some tag ideas. And as shown before in the picture, we have then a relationship between the transport queue and the dedicated stream tags. The next slide, incremental updates queue, how this works. Then looking into this again, it's important to know that the incremental updates to basic operation is only a read operation. So the client cannot create update or delete incremental updates queue directly. It's associated with the transport queue automatically, as I stated, and if there is a request, for example, to a dedicated transport queue, we have here also the link of the transport queue, and then the dedicated, for example, information that's then forwarded to the client. This is related to our requirements that we have stated here, and yeah, that is how the incremental update works. So next slide, individual updates. So here we have the pull read, push read. Important if we have now a client pull. So it's to get information and update the UI, and this looks like followed. Next slide, please. Yeah. So we have here again the client pull with the path, and then it's associated here the information, for example, a cost map that is then pulled down to the client, the normal Alto information, one can say, that's needed. Then the server push is, and now it comes to the interesting thing, and the relationship also to HTTP what's a little bit tricky. So the server push is also the client needs to have an information more or less on which way the server push the information, and we use, as mentioned earlier, the push promise mechanism, and and how this is established, that's shown in the next slide. We can move this. So the server push, as an initiation example, as shown before, we have here the sequence number and the dedicated tags. So if the client has no match, it chooses, let's say, the first entry, and if the client has already some matching criteria, it chooses the next the next number. And when now going to the push promise mechanism of HTTP2, for example, then the server pushes, for example, a dedicated stream, and here the information in which stream then the relevant information of this Alto solver is then pushed down towards the client. Let's say, and therefore the client knows in which queue or where the incremental update happens. And then also receiver set information, how it is. This read get status delete. For sure the client in case has the opportunity to delete also the transport queue, but in case also connection is not available, then, then from the point of view of the client, the transport queue is also closed. Then next slide. Stream management is also important. How is now all this stuff? It was more or less the intermediate layer between the Alto and the HTTP2, but we have also a relationship how stream management is then done. The objectives are here to allow concurrency of the streams, to reduce latency, reduce the minimum numbers of streams, etc. That's more or less the goal of HTTP2. And here is now shown the relationship between the frame level out and header suite out. So important thing is that we use something like a stream ID, and the stream ID is then written down in the stream identifier or in the stream dependency. If we create a transport queue, so the stream dependency is 0 because nothing is there before. Let's go please to the next slide. And for sure, if you close transport queue, it must be sure that there is no stream dependency, and then also the relevant information is then written down in the fields appropriately. And close transport queue, and then, for example, it's if you have here just a request or wanted to read something, then the stream ID needs also be written down, and then for sure, as long as something is streamed, then the stream dependency is not 0, and the identifier is written down. And same thing with the promised stream ID. So this is then the consequence of the concept that this needs to be worked together. Yeah, I think this is setting maximum of concurrent streams. Yeah, this is some detail. Each push needs to open a new stream and stream open a transport queue. I think that we can omit this slide and go to the next one then, please. And yeah, and then we now come to discussion and open points. And yeah, open points is what is missing. Yeah, so we do not create generic message, or that does not allow creation of generic message queue, and the client cannot publish info shared with other clients. So that is something. So we have not the ability to have a direct exchange or things. We were also aware of the broker discussion that has done, so we haven't looked so into details, but these are also options that can be discussed. Yeah, and then the capability of negation. We have, as mentioned earlier, this requirement is not addressed in the draft. Next slide, and also calendar semantics is not addressed. Yeah, and that's it. And now we can discuss or get your feedback.
Okay, thanks, Ronan. Actually, good presentation. So actually, I have some comments on the slides. Actually, so in the page 25, is there any out of order delivery issue for streaming management?
If there, no, I see no issues. Do I? Can you go back to slide 25? It was 25, Jin.
Yeah, 25.
25. Next one. Okay. Objectives. So, what was the question? Do you see any issues regarding this?
Third bullet. I'm just wondering because for stream you have dependency, so it enforces that such kind of dependency among streaming. So when you send a stream, is any out of order delivery issues?
Yeah, and this is done by
Jim,
the.
can I answer the question?
Yeah, you can, but
Yeah.
this is managed by. But
Yeah.
go ahead, Richard.
Yeah, I would like to answer this question because this is excellent. And okay, so yes, so there are a lot of streams going on right inside the system, because that's really the purpose of using HTTP2 for streaming concurrency. For example, from the design, of course, the newest version has not been posted, and all the details, of course, are only posted on deck of slides. We were very careful that there will be no out-of-order delivery, and of course, we need to go over a very formal proof. But let me just give you a sense about why we don't have out-of-order delivery. For example, the main thing which we're trying to push through using the new transport is to send increment updates. There are actually multiple mechanisms to make sure that we don't have order delivery of the increment updates. And number one is that all the push promise, they are only sent into a single stream, which is a stream which is open for this particular transport queue. So therefore, because if you're inside a single stream and you're carried by TCP, and all the packets inside the single stream will be delivered in order by TCP. So therefore, all the push promise one by one will be sent to the client in order. So therefore, if the client will process all the push promise in order, and therefore the client actually can know, for example, push promise 4, push promise 6, and 8, and 20, they're all sent in order. And so therefore, the client can know the order of the increment update, so therefore they're safe. And number two, there's also building a mechanism and to assign sequential sequence number to the increment updates. So therefore, the client actually can check into it. So therefore, the client can really do it in the transport layer using stream, or can also go to application layer to use the sequence number. So therefore, there are two ways to protect the in-order delivery. So therefore, I think that's an example, because that's the main part. we are sure, but of course we want to eventually write down some kind of formal proof that there'll be no out delivery in terms of the requirement. Of course, otherwise actually we want to maximize auto delivery as long as there's no dependency.
Okay. So another question, actually, I want to make sure the auto new transport doesn't require, extension to the existing HTTP protocols. Is that right?
Yes. And so Roland can also answer, right? Of course, I think from the way we design is we make sure we only use the central HTTP2 capabilities. Of course, we are using the assignment, right? For example, here Roland showed this particular figure, and we're trying to use HTTP2 capabilities. For example, how to assign the stream dependencies, and how to assign the identifiers and so on, and how to assign which requests to which streams to maximize the leverage of the capability. For example, also assign, for example, weights to really allow some kind of scheduling, but everything capabilities will be inside HTTP2. Of course, the API need to be a little bit more careful when the client or the server, input client, is using HTTP2, because the API should really allow the application, the client, to specify, okay, for this request, send to this particular stream. For this one, please send to this stream. And then, of course, the server also need to be conforming in the sense that the server should pick the right when they send the request, and it must be conforming as well. So therefore, server must send the packets into the right stream. Otherwise, we don't really need any modification of HTTP2. I think that was the requirement.
Okay. Last question from me actually is, for auto protocol, you define 4 functionality: transport queue, incremental update request, and also receiver set. So for all these 4 functionality will be mandatory, or some are just optional?
Okay, so given that I'm on the queue already, they are all necessary to really get incremental push updates. But if you don't want incremental push updates, for example, in the initial request, when the increment updates flag is set to be false, which is true can be by default actually true, but of course you can make it false, and then the increment updates feature will be turned off. So therefore, basically, there's no increment. So therefore, if application only wants to provide a way to provide this insight to the large-scale deployment to show that there are a large number of clients watching, and you can turn off increment updates. But now the client can only see the queue.
Okay. Thank you. So any other comments from the floor? So Rona, you have already completed your slides. I see you have some open issue you haven't discussed, or you finished?
The open issues, we need to address these open issues. At the moment, I cannot say when it is finished. We also need to check, especially in the capability negotiation, how this works. So we at the beginning here in the analyzing how to solve this.
Okay. So given the time limit, actually, I think maybe we can move on. And for some open issue, we can take it to the list, and we can decide how to move this work forward.
So we can bring this into this draft, or we can separate it and do in a separate work the open issues, because I think the main issues regarding the transport and HTTP2 are already addressed here in this draft. I think the mandatory things the main things are already addressed and described.
Okay. So let's for the open issue take it to the list, and we can see how to.
Yeah.
Yeah.
So for me, I'm quite open, but potentially it would make sense to split some work. But let's do it. Discuss on the list. Both ways are possible.
Yeah. So Richard, do you have any comments?
Yeah, I do want to get one question quickly. Given that we have other people here, is this design is very, very HTTP2 specific. And the guidance, I think Roland and this design team, we discuss is how much should we consider essential HTTP3, like a quick? Any guidance, and we should really just get this one done and focusing on HTTP2, because quick somehow HTTP3 would open a total different way. For example, all the stream assignment, somehow all just like a dependency, they're all quite HTTP2 specific. So any guidance from the working group to us?
My suggestion is to get a HTTP2 solid, and then we can make experimental on quick.
So my mute echo, oh, there it is. Okay, walking into the queue, I guess. HTTP3's application interface should be very similar to HTTP2. So I'm a little surprised that it requires a lot of re-engineering to update. I mean, can you say more about it?
So Martin, for example, I believe for ours, this one, we are, for example, if you look at this current slide, it is depends on, for example, all this blocking, for example, all the streams, because fundamentally everything will be underlying. There's a single TCP stream running, right? Because when you interleave everything, it's a single TCP stream, because HTTP2 is essentially a single TCP running on a single TCP. So therefore, a lot of, for example, all the other things probably would be very safe. And so therefore, on the client side, on the server side, you probably don't worry about all the other delivery at all, because TCP enforcing essentially a single stream. Of course, you still have issue of head of line blocking in this level, even though you interleave all the streams. And my understanding of quick HTTP3 would be then this kind of headline blocking will disappear, right? Because they're using essential different UDP, and you're not going to, if there's a single packet loss, you're not going to block everything below, behind it. So therefore, then we need to really check if that will cause potential issues for us in terms of, at least may not be the functionality, but at least in terms of performance or design requirement. So therefore, we then need to investigate to see what the impact it really is.
So you're concerned that you need ordered delivery between the streams?
Maybe add is buffering and those type of things inside the client or server side, because here we're assuming some optimization assuming somehow a packet will be always delivered in order, because TCP really delivers everything in order, even when you interleave different streams.
Yeah. So my understanding, I could be correct here. My understanding of HTTP2 is that HTTP2 is not even really promising you order delivery between the streams, because the protocol could be flow controlling the streams differently, etc. If it's just a matter of you like thinking about it a little bit, I would encourage you to do that, because HTTP3 is going to be an RFC before this is. Right. If it turns out that you need a bunch more protocol machinery to support HTTP3, then that would be a different discussion to have. Sure. I don't know if I want to make this 20 pages longer or something, because to support HTTP3, like that maybe could be a different document. But like I mean, it's easy for me to say, but I would encourage you to like do a little bit of analysis. I'm surprised to learn that this is potentially a concern, and I would hope it would turn out not to be.
Sure. We investigate, but let us clarify with you. So if we deliver this document initially, for example, by the next IETF, and we're mostly very specific to HTTP only, and we leave the work of looking at the compatibility or impact of HTTP3 to be the future work, are you happy, or working group happy, or that working group would recommend that we should always, like initially, already start look at into the impact of potential HTTP3?
certainly like you know, like the document. So first of all, it is perfectly fine to like for early versions of the draft to just consider HP2 and like consider HP3 later. So I would say that to me, the case where we do the analysis, it turns out that HP3 does require like a bunch of additional specification, I'd be 100% fine with submitting it as is. Now, in the case where we just do not do the analysis, that would I would not like that. I would have to think about whether that would be like unacceptable. My inclination would be to say that I would probably grudgingly accept something where we'd just not done the analysis, but that seems like just something to do. Like, in my opinion, that's kind of a due diligence thing to do.
Okay.
But again, like I don't know if I want to put the full force of my AD role behind that assertion. As an individual, I would say that. Let's say for now. Does that make sense?
Yeah, I think it makes sense to me because Roland, what do you think, right? Because Roland is essentially Roland is guiding the most thing. We're focusing on HP2. Roland, what do you think?
We need to go to Q. So when we originally discussed this, the main motivation was to focus on HTTP2 because it was mandatory and it was a quick way forward. And so we didn't focus on HTTP2 not to overload the work. So in my opinion, the analysis needs to be done too. And I'm happy to go in this direction.
As I said, like when we chartered this, I was operating an assumption that the upper layer interface for HP2 and 3 were almost identical, and that the value proposition of the application was almost identical, and that there should not be a bunch of more design. If that turns out to be untrue, then I'm 100% comfortable just shipping this as an HP2 RFC, and like maybe if there's the demand later doing it for H3 separately. But again, my initial guess coming in is that is actually not the case, and that it is essentially the same mapping. But I could be proven wrong. Thanks.
Any other question?
Okay, thanks, Ron. Yeah.
Thank you.
I think no. Yeah, thanks, Roland. Let's move on to the next topic. I think it's Jody and Kai. You will join present.
Yeah. So I'm going to be sharing on my laptop. Can I be allowed? Actually, so I'm going to do that myself. Actually. Okay.
Jody, I think you can take away.
Yep. Hi, yeah, I'm Jordi from Qualcomm, and this one? Cool.
Yep, and this is Kai from Sichuan University.
Yeah, so Kai and I are actually going to be talking about the Alto code base project, and so I'm going to start, and then Kai is going to take over. Yeah, so I'm actually, well, yeah, okay, yeah. Because most of you are familiar, so I'm going to sort of skip through, even though the slide deck is self-contained, so because it's going to be offline, so people can actually take a look at the slide deck and sort of think of this as a self-contained deck. But mostly I'm going to skip through this slide here to begin with. And what I'll say to you guys is that, we came to the realization that to help Alto get some visibility and actually adoption, basically, that there is a need to have a code base for Alto. Actually, there's already a code base, and there's an Open Alto project that Kai and Jensen and others have actually been leading. There's a need to bring it up to speed and actually have sort of a community to help sort of drive that development. And the reason we think this is relevant is because we think that visibility, network visibility, is very important for the kind of applications we're looking at these days. And Alto provides a key component for that visibility, specifically in applications like edge computing, for instance. We're going to be talking about that in a second. Yeah, and many others, actually, not just edge computing, but many others. Really, if you think about how do we get application performance, it's really three components: visibility, intelligence, and controllability. And so with so much going on controllability and so much effort, we think visibility is lagging behind. And so without proper visibility, it's very hard to do control and then sort of make intelligent decisions. So that's what this is sort of about in this case, to help Alto get some visibility through running code and trying to bring the community together. There are actually several efforts already going on with different vendors, but it's sort of fragmented. And because we're going to be looking at many different kinds of networks, we think that we can really leverage some networking effects here and sort of build that code base. So if you look at the Alto architecture, which I'm sure most of you understand already, just two main building blocks: the Alto server and the Alto client, right? And so there's a Northbound API and a Southbound API, and the services provided by the Alto, the visibility services in between. And so on the Northbound, basically you're interfacing with applications. So a few examples, but you can see it. Some of these are coming from the Edge Cloud already. So XR, V2X, IoT, and then the hackathon demo we put over the weekend was with science networks. Another very interesting use case. And then CDNs, of course. Historically, Alto has been very predominant on CDNs and originally back to the original days on P2P. But as you can see, the applications are evolving and sort of the need to have this visibility and on this new landscape, basically. But in the Southbound, we're looking at actually multi-domain networks, right? So many different components, and with the convergence of the edge and the IP together, the wireless and the core IP at the edge on the edge computing side, it's a multi-domain problem, really. So spanning from data centers, which are in the core, but also in the edge, and then WANs, the backhaul, mid-haul, front-haul, RAN, mobile core, multi-domain. So this sort of landscape tells us that we could really leverage by sort of bringing some code base together and not having to reinvent the wheel. Developing plugins for different SDN controllers, and then providing some code reference for the application side, and so on and so forth. So the effort here is to sort of leverage all these efforts to sort of not having to reinvent the wheel. Yeah, so let's talk then how does that map actually? So again, a different view, but the same picture essentially. So yeah, so again, Northbound API, Southbound API, and then we're looking at building some open sourcing some of these components here, building some components here that would allow to avoid having to develop this over and over. Where value is really being created is at the core here, but and then you have the Southbound API plugins to interface with the various SDN controllers. So over the weekend, we demonstrated integration with Mininet, but also Open Alto already integrates with Open Daylight. But of course, there's a need to sort of integrate more with more SDN controllers to help adoption of the standard, right? The same thing for the IETF, for the Alto client side. And then you would have the APIs potentially being open, and then but then vendors could also develop their own components within this picture, basically. So yeah, so there's this. Okay, I want to talk a little bit about before I hand it over to Kai, about how do we envision this happening, basically. So we think that the hackathons actually provide a sort of a good mechanism here. So we're looking at the Alto code-based project aims at providing a parallel track to the working group's standardization effort towards implementing the features introduced in the latest RFCs. That's one. But then, the IETF hackathons, we intend to use them as 3 checkpoints a year for us to test interoperability, test the sort of the new features, and demonstrate them and socialize them and get feedback, basically on running code. So and the focus of this effort is also going to be on really on production use cases, right? So really applications that are already running, and how can we help them by bringing more visibility, like the one we over the weekend with science traffic, with Throughput, and so on. So yeah, identify and build production open source environments for use cases and deployment, and sort of follow like the lean startup approach, where really driving this by use cases that are meaningful. Many of you here actually have use cases that are relevant. We want to know about them, and then what we plan to do is, starting next week from the hackathon, we're going to regroup and then collect all the feedback from this week, look at all the possible use cases, and select maybe one or two and work through them for the next hackathon, basically. So, and we're going to continue to do this as we continue to build a code base as well, right? So, 3 checkpoints, and in between, there's a time period here of 2-3 weeks where we are going to be opening in the Alto working group suggestions. We're already getting some suggestions on which features, which use cases are important, and then select one, and then aim at demonstration in the next hackathon as we continue to build that code base. Okay. Yeah. So basically, I don't have to go through the whole thing here, but we are invoking the community for participation. And then this is actually going to be, we're driving this through, there's a lot of interest from the students actually to participate. And this is a big thank you to Richard Yang, Professor Richard Yang and Professor Kai, from Yale University and Sichuan University, and then for bringing the students. It was actually a very good experience for the past month, working with them. So we envision these 2 roles, developers and mentors. Mentors are usually experienced people from the IETF Alto working group, basically. And then developers are usually coming from universities, students that are interested in learning, and on interesting production use cases. And then something that's really running on a standard. We think it can be a really good learning experience. And so today we have 2-3 universities already participating, but we also call for other universities that might be interested in participating. So we're already potentially discussing with maybe UPC and other universities. We really want to make this also sort of comprehensive in terms of people who might want to participate. Project resources. So we're gonna leverage GitHub, some of the new features for sort of a Scrum management, if you will. And that's an example of the dashboard, the Scrum dashboard that we use for the hackathon. This is now completed. Basically, next week we're going to be sort of moving on to the next one. So at this point, Kai, do you want to take over?
Yep. Thank you, Jordi. So can everyone hear me?
Yeah. Go ahead.
Okay, sounds good. So so after Jordi's introduction, I'll give some update on the auto deployment and also the status of the code base and also the demo that we did during the IETF hackathon. So next page, please. So as part of the charter item, we're actually collecting information about existing deployment using Auto, and we have the wiki on the IETF webpage, which collects a list of implementations, and we also there are some widely known deployments that we already see from the previous Auto working group. Because I think in 2008, the Comcast and other vendors actually conduct a relatively large scale field test for the P4P protocol, which is kind of a predecessor of the Auto protocol. And then we also have the Benelux deployment with Dash Telecom. I think it roughly starts around 2017 and has been running for several years. And they also use Auto as one of the Northbound APIs. And we are also working with Telefonica to use Auto for their CDN deployments. And I think from the deployment, we actually see there's actually a shift from for the work use cases. So previously, it's mostly about the P2P traffic, and right now it's shifting to CDN traffic. And we because we're also working with RUSU and also the Pacific Research Platform. and they are providing use cases such as 5G and I think they also mentioned like network slicing using techniques such as SRv6. So we are so we believe like the 5G techniques and also the large scale data management could be the next use cases that where Auto can play an important role. So next page, please. Okay, so so right now I'll be talking about the hackathon that we did for the IETF113, and here is basically a summary of the demo. So we are using Minet to simulate a network, and all the applications are actually running real software using basically in containers, and the demo environment is packed as multiple containers for future enhancement. Basically, so Jensen is doing most of the work, and we have the Dockers will be made available, public available through the IETF hackathon on GitHub. And so what we did during the IETF hackathon is actually we demonstrate the capabilities of Auto to select to give cost information between deep sources and a single client. So that basically enables the source selection based on the network map and cost map. And we also compute two types of costs. So these will be based on the new document, basically the performance metrics. And we are able to basically provide two metrics. We'll give the details later. And then for the hackathon, we actually conduct some development, and a new library written in Python is provided so that people can use these libraries to for future development. And also we add the auto-based replica selection support in the Rusio scientific data management system. So next page, please. So for people who are not familiar with the Rusio data management system, here's basically an introduction. So the Rusio data management system is used by LHC1, which is also part of this. We used to host the data generated by the Storm project, and the data will be actually spanned across multiple projects, including CMS and also Atlas. So these large-scale physical experiments. And what we did is we modified the Rusio client code, and we basically previously the Rusio client code enables the clients to select replicas based on, for example, random order or using geolocation information. And what we did in the hackathon is to enable basically to integrate Auto into integrated Auto client with Rusio code, and then we allow the Rusio client to select information collected by the Auto. Okay, so next page, please. And during the hackathon, we actually implement functionalities from these three drafts. So for the base protocol, we actually use the network map and cost map, and for the flow-based cost query, so these two are individual documents, and we actually implement a flow cost service so that we can express not only the cross product between source and destinations, but in a more fine-grained way. And also we implement two metrics in the Auto performance cost metric document. So next page, please. So here is a summary of what is achieved during the hackathon. So we have, like we said before, we have a client library in Python, and then we integrate Auto client with the certain Rusio replica download command. And we also we planned for 3 demos, and we were able to achieve 2 of them, and also the third one is still partially completed, and we are still working on it, and hopefully to get it working before the next hackathon. And then we also have some southbound auto integration with SDN. So and during the process, we're actually using so what Jody has mentioned before, that we're using the Scrum board to basically keep the software management. Yep. So next page, please. And here is basically the two auto metrics that we implement during the hackathon. So the first is actually the one-way delay metric, and the second is available bandwidth. So next page, please. And so here is a list of the Docker images that we used during the as the test environment. So some of the containers are provided by the Rusio project. So for example, the Rusio container basically is where the client is located, and then we have the XRD container. Basically, that's where the data are stored, and then we have the the ODL container, which is used to generate the auto maps. So next page, please. And so here is actually some screenshots for the demo. First, we are using the container net. Basically, a container net is a container that enables the containers to be connected through a virtual network. So here, we use container net to construct a network that looks like this, and then from this network, we actually construct two auto resources. The first is the auto network map, and for the network map, we actually group the hosts based on the access link, and then we collect the bandwidth information between the hosts as the auto cost and provide it through the auto cost map. And the third step is we actually by passing the address of the auto cost map to the Rusio command, which we have modified to integrate the auto capabilities, and then it enables the sorting of the replicas based on the auto information. And because we are using bandwidth, so actually the sorting order is from the largest bandwidth to the smallest, and then we were able to select the one with the highest bandwidth in this demo. So next page, please. And here is the results that we get when we use S-Flow as the traffic monitor. And I think the figure on the left basically shows when we randomly select a replica, and the maximum bandwidth gain is about 4 to 5 times higher. So next page, please. And then in this figure, basically we're doing the same selection process, except that we're using a different matrix. We're not using the bandwidth information, but using the latency. And for latency, basically the sorting orders will be slightly different, and also in the increasing order. So we select the one with the smallest one-way latency, and then but for this use case, actually, because downloading is mostly determined by the bandwidth. So when we use the latency selection, it does not give the best performance, but actually, but it still shows that we enable the capability of like exposing this network information, providing this network visibility to the Rusio client. So next page, please. And here is what we're doing for demo 2. So we're actually providing the multiple throughput prediction for multiple flows. And here the screen, basically we're using we're initializing like multiple flow downloading requirements, and then we use prediction throughput prediction based on the basically network utility maximization model, and we modified the auto interfaces to support the flow cost service, so that the cost would not be provided for the cross product of sources and destinations, but for more fine-grained approaches. And this is actually proposed in one of the individual drafts, which we are pushing forward to become a working group document. So next page, please. And what is not fully achieved during the hackathon is the third demo is to so in the demo 1, we're actually starting a download for a single client, and in practice, what usually happens is where there actually are multiple concurrent downloads. And for multiple concurrent downloads, choosing the one with the maximum bandwidth may not be the optimal solution. And what we are trying to demonstrate in this demo is that maybe we can leverage the information provided in demo 2, basically the throughput prediction when there are concurrent TCP flows. So for demo 3, we're actually trying to developing basically to integrate the multiple flow throughput prediction capability into the Rusio client, but this is not fully completed, and we are hoping to get this demo done in the next IETF hackathon, and then we can maybe get also have like further demonstrations about how it can improve the performance. So next slide, please. Yep, I think this is, and so give the floor back to you, Jolly.
Yeah, thanks, Kai. Yeah, I guess any questions, but before, yeah, I just wanted to also say thank you because there's a lot of people actually who work endless hours for the last 10 days. Actually, this has been like a couple of months planning and so on, but the last 10 days, I should really say thank you because people stay 3 time zones and they stay late nights. So thank you all, everyone, for the patience and the hard work. Yeah. So any questions on this?
Yeah, Martin Duke, Google. Thanks. This is really interesting and pretty impressive. It was nice to see like 3 different drafts incorporated in this work that Kai presented. And I seem to recall CERN having deployed some stuff here. So is Rusio the service that already had Alto? So is the diff here from 7285 to adding the additional drafts, or is that a completely different thing?
So I think this is a new thing. Richard might have more historical background. We do have some. Yeah, Richard, you want to take actually?
Yeah. So Martin, to clarify, this code and 7285 and all the stuff, they're part of Rusio already. So of course, they are really need to finalize and do all the unit tests and so on. So, but overall, let me just clarify that Rusio is the data management system for CERN and for all the atlas and so on. And the workflow actually is complex. So workflow, typical what using their terminology. I don't know if there are any like certain people or Rusio people here doing the call here, but of course they can ask them to clarify. And we're mostly working with the project lead and Martin and Mario Lesnick, and they are the project leads of the Rusio team. And there's also Radu, who's the transfer lead. So therefore, they guided us about the integration of Alto and with the Rusio system. And for the Rusio at high level, there are 2 workload, what they call, and one workload is called the manual workload, which basically means whenever a client, for example, scientists, when they download the file, they want to really do analysis, and they would start something called a Rusio download, and that part actually worked done. So this part of code actually is already in the system. They probably, hopefully, we can get fully deployed onto the Rusio system and soon. And all the code, I think we went through the review last week. So therefore, hopefully, this will really become part of Rusio. But actually, the main workload is what they call the automatic workload, which is automatically replication of all the data into all kinds of sites. That part of code to do the integration need to modify their database schema, which is trickier. So we are hoping that we can really like hammer down the details with them for next week, and then we can start really modify the database schema and then integrate it into the total automated workload. So therefore, then we can claim that we have full integration of the both Alto. This moment mostly is for the manual workload, which is actually a smaller part of total workload. I don't know if that clarified or not.
Yeah, that was an interesting clarification, but I'm not. But my actual question was, prior to this project, did Rusio have any Alto support at all?
No, it doesn't.
Okay. So all right. So because at one time, I remember having explained to me that CERN had some sort of Alto deployment. Is that a different tool, or was that not accurate?
Whether so there's a deployment I mean, we're working with ESNet and the Pacific Research Platform,
Okay.
not on Alto yet, but on something called Gradient Graph, which is something I'm actually going to present in a couple of minutes. I don't know if that's a reference that you were connected science networks with. And we're actually going to be working with packaging that into Alto and deploying that at ESNet PRP, and starting with PRP, I should say, and then pivoting to potentially to ESNet. And then, yeah, and then so CERN, there's a lot of synergies because this, as you know, all networks are connected. So,
Yep.
yeah.
Okay, thanks. All right, I'll wait for that then.
Yeah, cool.
Okay, I think so. Thanks, Jody. Thanks, Kai, and you did a very good job for hackathon. Actually, build the code bases is very important for Auto. Let's move to the next topic. So, give the time limit. I want to suggest maybe Jody, you may only have 15 minutes for this topic.
Okay. Sorry about that. Now, yeah, sorry about that. Yeah, so I'm going to be talking about supporting bottleneck structure graphs in Auto, use cases and requirements. Yeah, right here, use cases and requirements, sorry. And yeah, so I'm going to skip through this, but you know, this is work actually coming from research. There's a couple of papers we published at Sigmetrics and SIGCOMM, and then you know, Professor Richard Yang about 9 months ago, reached out to us, you know, saying, you know, hey, this is interesting. Maybe could we discuss putting this into the Alto work, basically. So, first of all, thank you to Richard for reaching out, and it's been very interesting in 9 months, I guess, since then. And yeah, and thank you everyone for the coaching, actually, and the guidance from the, you know, from everyone at the Alto working group, really. So, but yeah, so this is an informational draft, and so the details, I'm going to skip the details, of course, but if you are more interested, you can look into the papers. And what I'll try to do is to introduce bottleneck structures briefly, and then we're going to talk about potential use cases for Alto, and then requirements. Let's see. So the context here, I'm going to pick on the congestion control problem. Say, so the conventional view on congestion control, basically for the last 30 years, is this idea that the performance of a flow is uniquely determined by its bottlenecking, right? So this comes from Jacobson's paper back in 1988 that literally saved the internet from congestion collapse, basically, by inventing the first congestion control algorithm. And this is a true statement, right? I mean, the performance of a flow, it is determined by its bottlenecking, right? But while this is a true statement, we realize that there is a much more sort of fundamental or intricate element going on in a communication network. The analogy here is with an iceberg. If a communication network were an iceberg, the notion that the flow, the performance of a flow is uniquely determined by its bottlenecking would be the tip of the iceberg. Underneath, what the submerged part is what we call the bottleneck structure, which really reveals system-wide performance and how flows and bottleneck links relate to each other and the forces that they exert on each other, basically. So let's see how that works. I'm going to just put a very simple example to see if we can capture the idea. And what's the relationship with Alto, basically? Because we're going to show that bottleneck structures are a very compact way to sort of summarize the state of the network that includes topology, routing, and flow information in a single D graph. And that actually allows you to quantify things and compute derivatives on a network. So it's a way to sort of capture the state of the network that applications could potentially leverage. So let's take as an example this network. So links are circles, so there are 4 links, link 1 through link 4, each one with a different capacity. Flows are lines, each one with a different color, so there are 6 flows. And I'm gonna skip forward and just show you what's the bottleneck structure. So this is the bottleneck structure of this network, basically. And then how do we read a bottleneck structure? So a bottleneck structure is read as follows. Links and flows are vertices in the graph. So for every flow and for every link, we have a vertex in the graph. If there is a directed edge from a link to a flow, then that flow is bottleneck at that link. If instead, like for instance, flow 3 is bottleneck at link 1 because there is a directed edge from link 1 to flow 3. If there is a directed edge from a flow to a link, then that flow traverses that link. That's the relationship. So flow 3 traverses link 2 because there's a directed edge from flow 3 to link 2. Because flow 3 is bottleneck at link 1, it also must traverse link 1. Therefore, this is a bidirectional edge, right? Whenever you're bottleneck, you have a bidirectional edge. Now, why this graph is relevant is because this graph actually allows us to both qualify and also quantify the forces that flows and bottlenecks exert on each other, and reveals a hierarchical structure, the submerged part of that iceberg, that tells us how to drive system-wide performance. If you want to know how this graph can be computed, it can be computed in polynomial time. You can actually compute this graph for a US-wide network in a fraction of a second. So this is kind of, the algorithms are highly scalable from that standpoint. But basically, I'm going to sort of talk about a couple of concepts only. One is the fact that this graph reveals how perturbations on a network propagate through the system, basically, the ripple effects. Suppose that there's a perturbation on a link. What that means, that could be several things. For instance, if it's a wireless link, could be the signal-to-noise ratio is changing. So what the graph tells us that if there's a perturbation on link 2, that's going to have an effect on flows that can be reached from this link, according to the bottleneck structure. So this tells us that only these flows here, which are reachable, that they have a path, will be affected by such perturbations, but these flows will not be affected because I cannot go from link 2 to flow 1. There is no path, it's broken here, and so on. So first, it tells us how things are interconnected. The same applies to flows. If there is a perturbation on a flow, if I traffic shape a flow, that's going to create a ripple effect on the network, and it tells us how it propagates, basically. So far, we've been talking about the sort of the qualitative aspects of the problem. But the other element is that bottleneck structures are actually computational graphs themselves. We can also use them to compute the magnitude of change. If I have a perturbation, I can quantify how much the change is. How much is that going to induce a change on a flow, basically? And so, what is a perturbation? A perturbation is basically taking a derivative on the system, right? So a small, like an infinitesimal change on a link or a flow rate. That's going to have an effect. That's like taking a derivative. So once we have a tool that allows us to compute derivatives, that is a tool to help us optimize application performance. And that's the connection with Alto. Bottleneck structures, we think that can be a good way to summarize the state of a network and empower applications to make this, figure out how to do better routing, how to do better flow traffic shaping or scale rate limiting, for instance, for XR applications, augmented reality, that you need to sort of encode the rate of your sender according to the multi-domain available bandwidth. Sort of you could actually use this kind of framework. So I'm not going to go into this, but this is a tool to also quantify these changes and compute derivatives. So so anyway, this notion that can a butterfly in Mexico create a tornado in Asia? Of course, the answer is no. But everything is interrelated, and bottleneck structures tells us how what's the effect of a butterfly flapping its wings in Mexico, in China, say, for instance. So, yeah, I'm actually going to skip through this. The slide deck is there, and then I'm just going to sort of jump into. Yeah, so this just reflects the idea that you can actually compute what we call gradients or derivatives using the bottleneck structure. And the bottleneck structure is, think of it as a computational graph. So one of the values is that this allows us to do these calculations very efficiently. Because these are delta calculations on a graph. So if you're trying to solve these problems using LP, rapidly they are not scalable because you have millions of flows and so on, so it's hard. But these kind of calculations you can actually do 2 or 3 orders of magnitude faster using these techniques. And so it's not only that just quantify, qualify, but also the speed that we can do these calculations. And we're looking at sort of doing this kind of analysis in many cases, sort of near real-time compute. Okay, so I'm going to skip through these. But types of perturbations. So perturbations are derivatives, basically. So and so we can compute many different kinds of perturbations and think of them as derivatives. Let me actually skip through these and just jump into the Alto use cases. So we have this sort of tree. We realize that bottleneck structures, they are sort of a foundational element, if you will. And so that's what, through the research, we realized that there are potentially many applications. You could use them network design, traffic engineering, AI even, because bottleneck structures are a computational graph, and neural networks are computational graphs too. So you could think of bottleneck structures as a neural network itself. So but the point about sort of the work here is also, how does this get connected? We think that there's a strong connection with Alto, thanks to, again, Richard for connecting. And also, but then also throughout this week here participating, you can see that in many different working groups, there are potential connections, basically. So I listed some of them here, but we're still exploring, and we look forward, starting from the Alto, to see how we could explore potential, cross working group collaborations. Yeah, use cases. You'll have them in the iDraft, basically. So you want to look at them, and then what I'm going to do is I'm going to pick on one of these use cases, optimize joint routing and congestion control. And for this one, we have a use case. What we do here in the iDraft is actually, we take an arbitrary topology. We actually choose the B4 topology, Google's B4 topology. So this is actually back from 2013 SIGCOMM paper. So it's a simplified. Now, of course, there has many more data centers. But and then I'm gonna just show you the more sort of human readable version of that slide. So this is the subset, I guess, of the Google's B4 network with links across the globe. And then we're going to compute the bottleneck structure of this network. And what you get is this one. So this is in the iDraft, but I'm going to make this more user-friendly. What the assumption here is that I'm going to make some kind of random assumptions or ad hoc. That every link has 10 gigabits per second capacity, and that the two links between the transatlantic links have 25 gigabits per second. And then I'm just going to make a very simple use case, which is every pair of data centers from US and Europe are connected both ways. Okay. In fact, before runs as a sort of multi-path network, but in this case, we're going to assume a single path. So you can actually compute the bottleneck structure of that, and this is what you get. And then you can start reasoning, okay, if I want to do a large data set transfer, which path should I be using? And so, for instance, here in the bottleneck structure, we see that, the transatlantic links are at this level of the bottleneck structure, and these two links are here. I highlighted these two links because they are sort of relevant. There's this property that the links at the top get less bandwidth. So these are actually the links that are sort of more bottleneck. There's a notion of being more influential because these links actually influence the performance of the whole network. So that they tend to be more relevant. And then what I'm going to do, I'm actually going to skip through in the interest of time, but basically here what we do in this use case is I need to transfer data from this point to this point. I have multiple choices, and I'm going to use the bottleneck structure to predict the performance of the RAID. This is sort of like solving the joint routing and congestion control problem together, because what bottleneck structures do is model the congestion control algorithm and tell you, if I place a flow on this network according to this path, that's going to create a ripple effect, and I can compute what congestion control will do and get you that rate, basically, after you place the flow. And if you do that, then basically, in this case, we show that it's actually better to not use the shortest path, that you're going to get more bandwidth if you use the non-shortest path. And so some of these outcomes are non-intuitive, basically, and it allows you to reason about them. So, yeah, we have a few requirements that we start sort of discuss in the group or through the draft. We're starting to discuss it. This is very preliminary, I should say. The initial requirements are in the draft, so maybe we don't have to actually time because to do that, but they are in the draft. They are very intuitive at this point, I think, and the requirements are actually structured in 4 groups. one is the BSG abstraction. Do we want to create an abstraction for bottleneck structures? That's an object basically that would go into the specification. Requirements number 2, information received from the network. So what kind of information we need to extract from the network in order to compute the bottleneck structure? Requirements regarding the information passed to the application. So you can think that one is the southbound, the other is the northbound. This would be the northbound. What information, given a bottleneck structure, what information we pass to the application? Do we want to pass the whole bottleneck structure as a compact way to represent the state, or maybe some elements of it? And then features that would go into this potential bottleneck structure graph service, and some initial sort of debate or discussion about what features we want to put into for consideration, basically. So welcome any feedback. At this point, we're just discussing this, understanding what's the connection, and trying to get some coaching guidance on the steps here. Yeah, looking forward to that conversation.
Thanks, Jody. Actually, given the time limit, we don't have time to take a question. Maybe we can take it to the list. You can, introduce your draft on the list, and we can keep on discussing on the Auto weekly WebEx meeting. Next, let's move to Luis.
Maybe you have to. Hello, this is Luis Contreras from Telefónica. Yeah, next slide, please. Oh. Okay, thank you. Oh. Okay. Yeah, well, the idea of this presentation is simply to comment about the compute awareness capabilities and how what could be the role of Alto in this story. So, content service provider for sure from a long time ago, but now also operators are developing the networks by adding compute capabilities spread and distributed across the network. This is not necessarily related to the edge, for sure. The edge is there, but we could talk in general terms about computing capabilities. So cloud, more or less centralized cloud data centers, and for sure also edge computing. So it seems to be interesting to know about where and how these computing capabilities are being connected, and also to extract from them also even metrics. So to understand to what would be the latency, what would be the throughput that we could have for reaching whatever amount of CPUs and status in the cloud part. This is clear for the resources, but also this could be even augmented for connecting a service function. So to have a notion of where we can find a P gateway, or where we can deploy a P gateway, or whatever other function that we could consider. So there is some space for optimization on service delivery, managing, and planning by combining the information of compute and the working all together. So breaking those silos that are today somehow decoupled, and permitting informed decisions for placing of functions, or for simply connecting and accessing resources. So next, please. So yeah, for finishing this week, there was both named Khan about compute aware networking that precisely was trying to address this same problem space, that from the routing perspective. So trying to define routing solutions for that. We consider that Alto can address the same problem in space, but from a different engineering perspective, from a different engineering point of view or angle. So the idea would be to have Alto as a element capable of exposing combined information between network and compute capabilities, so adding metric resources, topology view, and reachability, and so on and so far. In fact, there are 2 existing pieces of work on this subject. I put there the drafts. And just simply, well, the final message for this, the goal that we were considering with this presentation would be to explore how Alto can contribute on this. So to define a solution to this problem space, trying to propose this as a subject for future working group rechartering. And with this, with that, I finish. So thank you.
Okay, thanks, Luis. Actually, good topic. Actually, Ken, I think has a lot of, for auto actually design for the seeding application actually, for computer aware networking actually, very similar to the seeding application. So I think auto can be the potential solution for computer aware networking. So let's keep on discussing this and cook your draft. And for audience, if you have any input to this, and feel free to join on the mailing list or contact with Luis and other proponent for the CAN. And with this, actually, we actually at the end of the meeting. And so, Matt, do you have any last words, or Martin?
No, it comments from my
Okay.
side. Thank you all.
Yes.
All the presenters.
Actually, yeah, Ian is not here, but I like to thank Ian to serve the author, and he will be the outgoing author chair. Yeah. So thanks of all, and let's close this meeting.